In this segment, we'll examine a nice example of how the purely motoric account of gestural phonology can explain a couple of well-attested sound phenomena in a phrase such as perfect memory. In the middle of this phrase is the three-consonant sequence k, t, m. In the score here, you can see that the k begins at about 50 frames in. To be honest, I have no idea how long a frame is, but from the duration of the overall production, I'd estimate that one frame equals about 10 milliseconds, so 50 frames in would be about 500 milliseconds from the beginning of the utterance. Notice how the articulatory patterns for the t sound overlap with the patterns for the k sound, with the end of the t being about 5 to 10 frames, or 50 to 100 milliseconds, after the end of the k sound. So when you think about the release of the k sound, what happens to the air when the closure at the soft palate is released? Well, the air will rush through the space between the tongue back and the soft palate, but it still won't be able to get out of the mouth because the tongue tip is still creating a closure at the alveolar ridge. So no air will actually escape from the mouth until the tongue tip releases its constriction at the alveolar ridge. The result of this is that the listener won't hear a release of k. They'll only hear a release of t. And this is why we often say that if two stop consonants occur in sequence, the first will be unreleased. It doesn't actually mean that we don't release the articulatory constriction of that first stop. It's just that there's a second constriction that still prevents any air from being released. As a side note, you might be wondering why we even perceive that there is a k sound in this word, since we never hear the release of a k. The reason is that the tongue back gesture for k begins during the preceding vowel, and that tongue back movement will affect the vowel's formants in predictable ways. These effects, again, are referred to as a formant transition, and formant transitions are a very powerful way in which we hear which place of articulation a consonant is being produced at. Because it's the tongue back and not the tongue tip that's moving during the vowel, it's the velar place of articulation that we hear in that formant transition. The last thing to notice in this score is that after the t is released, there's still some time before the lips close for the sound in memory. The result of this delay before is that there's a slight pause between the two words. Whether the literal pause is perceived as an actual pause by a listener, though, is hard to predict. Remember, the release of the t is accompanied by aspiration, which might well cover the time between the two words, leading to a perception on the part of the listener of fairly continuous speech. So this production might sound something like perfect memory, with the aspiration of the t in perfect being very audible. This is the same phrase, but this time spoken more quickly. If we look quickly back at the last score, you'll see that the time scale is the same in both graphs. About 140 frames are shown, or about 1400 milliseconds. But in the last score, the word memory is only partly produced in that time, whereas here, the entire phrase is spoken by about frame 120, or in about 1200 milliseconds. The other salient characteristic of this production is how the same three-consonant sequence, k, t, m, is produced with a series of gestures in which all three movements overlap with each other. So, as the tongue back is closing for k, the tongue tip is already moving up to the alveolar ridge for t. And while both of these closures are active, the lips are also coming together for the sound. In this sequence of movements, consider the tongue tip. By the time it comes up to make its closure, air has already been stopped at the soft palate by the earlier movement of the tongue back. And when k releases, just as before, the air will have nowhere to go because the closure for t is still active and will stop any air escape. But then when the t releases, the air is going to try to go out of the mouth, and it won't be able to do so because the lips are already closed. True, you can see that the velum has already come down just a bit before the t is released, so you might think that this would result in nasal plosion, or the release of a stop through the nose. Much more likely is that voicing begins for the nasal consonant as the velum opens, which means that any contribution of nasal plosion is essentially masked by the much louder acoustic component of vocal fold vibration. So seeing this whole thing from the perspective of t, it's clear that by the time the tongue tip rises to start articulation of this sound, the tongue back has already been raised, and this is what will create a formant transition in the vowel, leading the listener to perceive a velar place of articulation. And then when the tongue tip releases, there's no audible release of the stop because the air burst is prevented by the labial closure for the sound, and the onset of vocal fold vibration would mask any other acoustic characteristics that would identify this sound as t. The result of all of this is that even if t is fully articulated, it won't be heard by a listener. This is an excellent representation of how you can have an articulatory gesture that produces the acoustic appearance of a deleted consonant. In a gestural phonology account, sound changes like these are explained through purely motoric means. No linguistic phenomena are called upon. Instead, this kind of sound deletion is viewed as an artifact of overlapping articulation. In the next segment, we'll see how gestural scores represent some of the basic contrasts and sound changes that are familiar from basic phonetics.